Turn your pages, turn your books to page 810, and we're going to do a scan and run of section 25.3, Fission and Fusion of Atomic Nuclei. Guide for reading, key concepts. What happens in a nuclear chain reaction? Why are spent fuel rods from nuclear reactions stored in water? How do fission reactions and fusion reactions differ? Vocabulary, fission, nuclear moderation, neutron moderation, and neutron absorption and fusion.
Connecting to your world. The sun appears as a fiery ball in the sky, so bright it should never be viewed with unprotected eyes. Although its surface temperature is about 5,800 K, the sun is not actually burning. If the energy given off by the sun were the product of a combustion reaction, the sun would have burned out approximately 2,000 years after it was formed, long before today. In this section, you will learn how energy is produced in the sun.
Nuclear fission. In a chain reaction, some of the neutrons produced react with other fissionable atoms, producing more neutrons when reacted with still more fissionable atoms.
Neutron moderation, neutron absorption.
Nuclear waste. Water cools the spent rods and also acts as a radiation shield to reduce the radiation levels. Nuclear fission. Fusion. Fusion reactions in which small nuclei combine release much more energy than fission reactions in which large nuclei split. Pictures!
Figure 25.10. In nuclear fission, a uranium-235 nucleus breaks into smaller nuclei and releases neutrons. Figure 20. Oh, do you want me to read all of them?
Just read all.
Yeah, go for it.
Go for it.
Figure 25.11. A nuclear reactor uses control fission to produce useful energy. The illustration shows the basic components of a nuclear reactor. Energy from the fission process heats the circulating coolant. The heated coolant is used to produce steam that turns a steam-driven turbine. The turbine drives a generator to produce electrical energy. Figure 25.12. Racks at the bottom of the spool contain spent fuel rods. The blue glow is from beta particles that the rods emit into the water. 25.13. In solar fusion, hydrogen nuclei fuse to produce helium nuclei.
Take out a piece of paper, MLA it.
This is notes, section 25.3.
First thing you're going to do is the 4 vocab words. And then you're going to do figure 25.13. Hey, can you pause it?
No.
That's mean.
And on the bottom of all this, put section 25.3, RQ1 and 2, page 813. And
Joshua, read the first question.
Explain what happens in a nuclear chain reaction.
okay,
Who's going to read the RQ?
capital I. In a chain reaction, comma, some of the neutrons produced react with other fissile atoms, comma, producing more neutrons, which react with still more fissionable atoms. Period. In a chain reaction, comma, some of the neutrons produced react with other fissile atoms, comma, producing more neutrons, which react with still more fissionable atoms. Period.
Very close enough.
Oh, that's number 2? Number 2.
So I'm gonna read the question.
Yeah.
Oh,
someone read the question.
Okay, read the question.
What's up? Why are spent fuel
rods from a nuclear reaction stored in water.
Number 2. Water. Capital W. Water cools the spent rods, comma. Water cools the spent rods, comma, and also acts as a radiation. And also acts as a radiation shield to reduce the radiation levels. Water cools the spent rods and also acts as a radiation shield to reduce the radiation levels. All right, pass it to the left.